In 5.5, what the authors of these worksheets finally decided to do was, hey, let's start quizzing them and seeing if they know all the stuff they're supposed to know halfway through the unit. I really, really like it. It is review. So in my opinion, what's going to happen is when I look at what we've taught about this, what's the sum of the interior angles of any polygon. We have some postulates and theorems about what the sum is. We had some properties of parallelograms, rhombuses, rectangles, squares, and then even trapezoids. And so because that's a lot of information, they decided to throw in a mid-unit review before we got into this 5.6 and 5.7 to make sure that you understood all the properties of these 4 different shapes. And most of those shapes are pretty simple. You've done them before, but just to clarify, what they're going to do is they're going to give you questions about rectangles and rhombuses and parallelograms and quadrilaterals and trapezoids and things that you're supposed to know about how to do each and every single one. So what I started with is that I want you to know you may have to get your notes out from 5.1, from 5.0, from 5.2, from 5.3. This is where being organized with your notes is going to be really, really helpful. Because as you're doing a problem, you might have to go, let me see, this problem is about a rhombus, and I forgot about rhombuses. And you might have to go back here and then look at a rhombus and then look and see, oh yeah, the diagonals are perpendicular. The diagonals create 90 degrees. That's how I find that angle. That's what you're going to have to do. So I start you off, oops, that's the wrong one. I want to go to this one. With that, it's review. Keep your notes out while you're doing this worksheet because it's a long one and you may not know all the properties off the top of your head like I do. That will help you. The second thing that you're going to have to do, the only thing that's new besides these review questions, is this idea. The idea of, hey, is a rhombus a parallelogram? Is a rectangle a parallelogram? Is a parallelogram a rectangle? Is a rectangle a square? And so on. So what I like your textbook, I know we don't really have a textbook in this class anymore, but back when we had a textbook, I took this picture from it, and I really like how it organized all the shapes that we've learned so far. We have above here polygons, and then we went specifically into quadrilaterals, and we talked about the special ones over here. Parallelograms, we had a section. Trapezoids has a section. And then we used to talk about these things. We don't talk about them anymore. Or we decided not to deal with any problems with it. So you're going to have to decide what's what. A couple of things that I had you write down is this red line. This graph shows that each subgroup is always a part of the group above it. Meaning a square is always a rectangle, but a rectangle is not always a square. But a rectangle is sometimes a square. Since a rectangle is defined as a parallelogram with 4 right angles, squares have 4 right angles. If the 4 right angles, if the 2 opposite sides, if the 4 sides are also congruent, then it's a square. So sometimes it's below it. It's always what's above it. A rhombus is always a parallelogram. A rhombus is always a quadrilateral. A quadrilateral is sometimes a parallelogram. It's sometimes a trapezoid. It's sometimes a kite. A trapezoid is sometimes an isosceles trapezoid, and so on. That's how it works. That's why I had you write that down. That's why I had you draw the picture. So now I have chosen 3 problems, 5, 10, and 13 are examples. If you want to do these on your worksheet, you can. This is number 5. If you want to do it with me, I would recommend doing so. It says, solve for the variables. Give the best name for each following. Give the best name for each of the following based on the given information. So, when you look at this shape, It says it's a quadrilateral. Well, let's see if we can be more specific. This side is congruent to this side. It has the congruent marks. This side is congruent to this side. When the opposite sides are congruent, that gives this a very specific name. Do you know what the name is? If you do, tell the person you're sitting next to what the name of it is. That scares me because I did not hear enough right answers. Oh my goodness gracious. Okay. When opposite sides are congruent, that makes it a parallelogram. Can it be a rectangle? We don't know if this is 90 or this is 90, but it says the perimeter is 90. Well, that means the outside distance added up. That's what that word means, just in case you didn't know. So then they ask us some other questions. They ask us, what's x, what's y, what's n? And this is why I chose this problem, because this is a nice middle-sized difficulty, and this is what you can expect on your chapter test. We'll throw one shape, throw in some x, a y, and a z, and say, hey, what's x, y, and z? Figure it out. Here's what you got to know. Let's do, the first letter is x. I wonder how I'm going to do that. Let's see. Here's an x. And here's an x. If this shape is a parallelogram, that must mean that the opposite sides are parallel. This has to be parallel to this. Now I got to figure out how these things are related to each other, and then I realize that there is something called a transversal that goes down this thing that connects this parallel line to this parallel line. And that brings me to the realization that these two angles are a certain type of angle. If you know what the name of this angle is, would you raise your hand so I can see how many know what the name of this thing is? 1, 2, 3, 4, 5, 6, 7. If you know the name of this and you are one of the 7 people, go ahead and say what you think it is out loud. Too scared to answer. That was not, yeah. I know it, but you couldn't say it. The words did not come out. These are called alternate interior angles. Alternate interior angles are the ones inside a Z. They're also called the Z angles that are congruent to each other. If you have parallel lines, the alternate interior angles are going to be equal to each other. You can set 7x minus 19 equal to the 5x plus 3. And then what can I do?
Can I get Adrian's bag? He said he loved it. Thank you.
You're welcome. And then what you can do is you could subtract 5x from both sides. 5x, take away 5x is 0. 7x minus 5x is 2x. Minus 19 equals 3. I want the x by itself, so I'm going to move the minus 19. I'm going to add 19 to the other side. So 2x is equal to 22. Since this is multiply, the opposite of multiply is divide. X is going to equal 11. Well, that is one part of the 3 parts we need to find. The next thing they ask us for is what's y? That's this angle right here. How's it going?
Good.
Good. This is right now. Raymond? Here you go. You need to take this. And there's somebody's asking to see you. You can go ahead and take that and go where you're supposed to go. Next thing, we need to figure out what y degree is. And so here's what I have to use. I'm going to use a different color here. I'm going to switch over to blue. And I'm going to look at this triangle. I know what x is, so I can actually figure out what this angle is. 5 times 11 plus 3. I know what this angle is, and these three should add up to 180 degrees. So what I'm going to do is I'm going to take this 11 and plug it back in and figure out 5 times 11 plus 3 is 55 plus 3, which is 58. I know what this angle is. It's 58 degrees. I know that 58 and 24 together add up to 82 degrees. So these three angles must add up to 180 degrees. So all I'm going to have to do is do 180 minus the 82. And I believe that means y has to be 98 degrees. Let me double check with the calculator that I have right here. That's what I get. The last one is the letter N. The letter N, I have a 5n plus 7 and I have a 3n plus 2, and there's a single congruent mark and a double congruent mark, which should tell you that they are not congruent to each other. This one is congruent to this side. So I'm going to switch over. I'm going to go to a different color. I'm going to go to green. This is 3n plus 2. This is now 3n plus 2. And double congruent is congruent to the other double. This is a 5n plus 7 on this side. What I'm going to have to do, because there is no rule for the outside other than this piece of information they gave me at the start. The perimeter is 90 centimeters. What does that mean? That means this plus this plus this plus this should equal 90. So we can do that and solve it to figure out what the value of n is. Let's do that. 5n plus 7, I'm going to put it right here, plus the 3n plus 2, plus the 5n plus 7, plus the 3n plus 2 should equal a perimeter of 90 centimeters. So I'm going to work that out. 510, 16n, 9 plus 9 is 18, equals 90. I'm going to subtract 18. 16n is equal to 90 minus 18 is 72. Then I'm going to divide that by 16. And this one does not come out nice and even. It actually comes out as a fraction. You can write your answer as a fraction or a decimal. I would accept it either way. Lot of different work. It's a review problem. Lots of different things. That is a normal problem on the quiz or on the test, just so you know. Next question I jump to. Number 10. There's a bunch of questions here that come from section 1 of your unit. It says find the number of sides for a convex polygon whose interior angle sum is 3060 degrees. Okay, well, what is that? I mean, if you don't remember, this is where I said you're going to need to maybe have your notes out, because in 5.1 we talked about the interior angle sum. There's a formula for that. You do not have to have them memorized, but you do have to know how to use them. This is equal to the sum of the interior angles. I'm going to ignore the other stuff at this point. So when I go over to this problem, I have to know that the sum of the interior angles, let's do sum of the interior angles, is equal to n minus 2 times 180. Well, what if that sum is 3060 60 degrees. Could we find the number of sides? Yes, you can. You just set it equal to that formula that we had, and it was in 5.1's notes. You could either distribute this if you wanted to. That's going to have one extra step. Or, since 180 is multiplying this group, you can do the opposite of multiply and divide. This will be the fastest way to do it. By dividing by 180, since you're multiplying by 180, you're dividing by 180, that goes in one time. 1 times n minus 2 is just n minus 2. Over here, I'm going to use a calculator. 3060 divided by 180 goes in 17 times. Add 2, and stands for the number of sides. How many sides does it have? It has 19 sides. It's a 19-gon. That's what you would call it. Just because I use this formula doesn't mean you're going to use this every single time. It's just, don't forget, the formulas are in 5.1. If you need a formula, pull it out. Last example I have for you is number 13. Everything else you're going to be using your notes to answer. This says, write all, some, or no, and then explain. Is it all rectangles are squares? Is it some rectangles are squares? Or is it no rectangles are squares? You're going to make a decision. It's one of those three things. What do you think it is? If you think you know what it is, tell the person you're sitting next to what you think of which word it is. I heard several correct answers. I heard a couple of incorrect answers. The correct answer is some. Rectangles, some rectangles are squares. If you look at what our chart was, the squares was below the rectangles. Squares are always a rectangle, but rectangles are sometimes a square because they're below it in the chart. Some rectangles are squares. Some rectangles, well, all rectangles have 4 right angles. Squares have 4 right angles and 4 congruent sides. Some rectangles are squares when they have 4 right angles and 4 congruent sides. But not all rectangles have 4 congruent sides. Only some of them do.
But if they had 4 right angles and 4 congruent sides, it would be a square. So it wouldn't be a rectangle.
A square and a rectangle are the same thing at that point in time. For example, this is a rectangle, and so I can keep squishing until this rectangle looks like this. And this rectangle is also a square. Rectangles are sometimes a square when it has the 4 congruent sides as well. Squares will always be defined as a rectangle, or a square is also a rhombus. It has both qualities together. Hopefully that makes sense. We'll stop your notes right there.